In dairy powder production, spray drying is an essential but often energy-intensive process that is invariably powered by fossil fuels. As one of Europe's largest dairy producers, Arla had a clear ambition to drastically reduce CO₂ emissions. In a proactive step, GEA and Arla conducted a holistic energy audit of Arla's milk powder factory in Svenstrup, Denmark. A mapping of energy streams revealed that spray drying accounted for a significant amount of CO₂ emissions, coupled with high natural gas usage. Additionally, the audit uncovered a large potential in waste heat recovery. To capitalize, Arla and GEA set out to tackle this challenge with a first-of-its-kind solution, namely the GEA AddCool heat pump system. GEA AddCool is a high-temperature heat pump system designed for spray dryers. It effectively draws waste heat from the plant as an efficient way of generating hot air for the dryer. Additionally, it provides cooling for the production line, offloading the chiller installation on site. The AddCool heat pump at Arla is powered by renewable electricity. It reduces the demand for natural gas, decreases the load on existing chillers, saves on energy use, and lowers water use and noise from the cooling tower, all while keeping production stable and product quality consistently high.
The system has been running for 1.5 years now. The expectations is fulfilled, and we get the savings in the energy, and also, of course, the emission we see decrease in. So yeah, it comes together, and it's monitored very well through the Inside Partner system, where we can follow the performance also. We definitely have seen very positive results from the AddCool system. It was producing as it was supposed to, almost from the beginning. Of course, there was some minor adjustments on the system, but we have agreed on the performance, and actually the performance was a little bit better than expected. The collaboration with GEA has been very positive because we have developed as a team together, and we have met a lot of obstacles and some complex situations where we have come up with some very creative solutions to the obstacles, and that's only something you can do when you work very closely together and understand each other. And also, the spray drying process is a very complex process, and GEA's expertise within this field has shown us that they were the right partner.
With a clear ambition to drive change, Arla is steadily shifting more of its energy consumption to renewable sources. The AddCool solution supports this transition with impressive results. Natural gas consumption dropped by 59%, cutting over 670,000 cubic meters per year, and annual CO₂ emissions fell by 1,500 tons.
Spray drying is one of the most energy-intensive processes in dairy production, especially milk powder. So decarbonizing this step significantly impacted our Scope 1 emissions, which is very important for us. Arla has committed to reducing Scope 1 and 2 emissions by 63% by 2030, and the high-temperature heat pump in a CAFE is a significant step into that journey. By replacing fossil-based heating with a high-temperature heat pump, the site significantly reduces its dependence on natural gas, which is one of the main contributors to carbon emissions at this site. If you are serious about meeting your sustainability targets, innovative solutions like these are very crucial, and electrifying high-temperature processes will clearly reduce your emissions. If I had to give you one advice, I would say not to wait for the perfect conditions. Start with your biggest emission sources, collaborate with forward-thinking suppliers, and share your learnings. One of the key learnings for us in this project was that sustainability and performance, including financials, can go hand in hand.
This AddCool project may be the first of its kind, but it's certainly not the last. Arla has shown a clear path forward, one that proves sustainability and performance can and must go hand in hand. It's more than a technical achievement. It's proof that bold climate ambitions can be met with smart engineering. That the future of dairy production doesn't just look efficient, it looks sustainable.